So we're going a little bit out of order here. We're going to go to 10.3. And again, this is going to be pretty quick. And we're looking at the nth term test for divergence. Okay, key here is that this is a test for divergence, not a test for convergence. And that's going to be important because as we go through these, some of them will tell us that it converges, but this one doesn't tell us that it converges. Okay, so you got to keep that in mind. All it does is tell us if it diverges. If it doesn't diverge, we don't know for sure that it converges. Okay, so here's the main premise here. If a series converges, then the limit of the nth term has to equal 0. So it's saying you go out so far, and you start adding basically nothing, and that will tell you that the series, it might converge. So this only tells us if the limit of the nth term does not equal 0, then we know for sure that that series diverges. Now, it's a super important test because it's like a weed out test. You can right away get rid of some if you know that they diverge. Okay, but you have to be careful because it only tells us if it converges. We can't say if it diverges. We can't say that if it does equal 0, it converges. It doesn't work that way. Okay, so if it does equal 0, it might converge, might not. But we would just have to do another test. So this is like a little simple test that we usually do the first time through when we see something, just to tell if we should go on or can we scrap that one. Okay, so let's look at something like this right here. Okay, so this is the rule for the nth term. So if I want to use this this series here, or this rule, I should say, all I'm going to do is I'm going to say, all right, let's look at the limit as n approaches infinity of, and we've got here our n squared, 5n squared plus 4. Now, we'll always try direct substitution. And actually, we know we would get infinity over infinity, and we could use L'Hopital's. Or you could remember just the n behaviors, that we have a rational expression. These have the same exponent, so it's going to equal 1/5. Okay, so since it did not equal 0, we're going to say that the series diverges by the nth term test. Okay, so one of the things that you have to be able to do is you have to say, which test did you use to come up with that? Okay, because remember, there's all these different tests, so we're going to let them know that we looked at the nth term test. Okay, let's look at another one. Let's say we have the sum as n goes from 1 to infinity of, let's see, n over n squared plus 1. Okay, so again here, if you notice, if we do the n behavior test, we could say, oh, this is bottom heavy, and that means that it would go to 0. Okay, so I'm going to say the limit as n approaches infinity, and I'm going to be lazy, of the whole thing is equal to 0. Okay, now, this doesn't tell us anything. It tells us, all it tells us is that it might converge and it might not. Remember, this test is only good at saying this for sure diverges, throw it in the trash. Okay, so we say that the test is inconclusive. The series may or may not converge. Okay, and we would use another test to figure it out, but we don't know any other tests, so we're going to keep it at that for right now. Okay, let's say we had something like the sum as n goes from 1 to infinity of n squared minus 1 of 2 to the n minus 1. Okay, so if I went ahead and I put in, if I did my limit and I put in the limit as n goes to infinity, because we have to show this part, this is the part of the test, of all of this, we would get infinity over infinity. We have the indeterminate form, so I would use L'Hopital's, and I would get limit as n approaches infinity of 2n over 2n, 2 to the n, natural log of 2. Okay, so this again, it's been a derivative that we haven't used in a while, so I thought that was good to bring that one up. Okay, we're going to get infinity over infinity. And so again, indeterminate form. Now, if this were open-ended, you'd be writing indeterminate form, use L'Hopital's rule. So I'm going to do it again, and I'm going to get 2 over whatever. I don't even care what that's going to equal, because I know that it's going to give me 2 over infinity, which is equal to 0. Okay? And again, I should have put the whole limit, blah, blah, blah. But you guys get the idea. Okay, so that is how that test works, and that's it. All done.